Are the following polynomial functions? If so, state the degree of the function. All right, let's take a look at example A and talk about what you need to look for when you're looking at polynomial functions. First thing you want to look for is to make sure that the coefficients are in fact real numbers. 7 and 2 are certainly real numbers, right? So what's not a real number? Something like the square root of -2 is not a real number, So in other words, anything that would be under a radical with an even index and you have a negative under there, that would not be acceptable. The other issue, of course, that you want to look for in a polynomial function, aside from those coefficients, is you want to make sure that the exponents on the variables are all positive values. In other words, you need to have something like x to the fourth, x to the third, that's okay, but x to the -4 power would not be okay, right? That would not be acceptable. So we have to make sure that the exponents there are positive. You also want to make sure that the domain for the function is all real numbers, right? And if that's not met, then it's not a polynomial function. Either way, I think example A looks like a polynomial function. It meets all the requirements. The graph of it is nice and smooth and continuous, although we aren't graphing it here, but that basically would be the case. I do want to mention one function that sometimes people might, going through the checklist there that I just mentioned, might get confused with. It'd be the absolute value function, absolute value of x. This graph, when you graph that function, has got this sharp angle here. The vertex is like a sharp point, right? Polynomial functions are supposed to be smooth and continuous. They can't do that. They can't come to those sharp, jagged edges like that. Basically, a polynomial function, the classic one, would be kind of like the parabola. It looks smooth when it comes to that turnaround, right? It doesn't come to a sharp point. So either way, absolute value function wouldn't be a polynomial function for sure. Okay, either way, going back to example A here, it certainly is a polynomial function. Then we just have to state its degree. So we would say that its degree is equal to 4. And what's the degree? Remember, the degree is just the highest power that you find on the variable for the function. So in this case, this is a function in x. The highest power you see on that variable x is 4. That is the degree of your polynomial then. All right, let's look at example B. B is not a polynomial function. I can tell right away because you have this 5 over x term, right? If you rewrote this, for example, you could write it as x squared minus 5 times x to the -1 power by bringing the x up. And if you do that, you can see that it no longer has positive exponents on the variable. So that would make it not a polynomial function. Also, you can tell the domain for the function is not all real numbers, right? You're not allowed to put 0 here, right? 0 cannot be in there, right? So x cannot equal to 0, because if you did that, the function would have an undefined point, and that means that it's not part of the domain. So 0 is not in the domain, but that's not acceptable for polynomial functions here, right? If g of x was a polynomial function, it would have to have a domain that's equal to all real numbers. That isn't true here, so again, it's not a polynomial function. So for either way you want to write it, whether you want to say because of the domain issue or you want to say because of the power on x, either way you'd have to say that it's not a polynomial function. Okay, from there let's look at C. For C, it's looking a little bit complicated, but really all this is a factored polynomial function. So they factored it for us, and because they factored it, some things are easier to see about it, but there are some things that are harder to see. For example, it's harder to see the degree, and it's also perhaps harder to tell that it's a polynomial function. So how can I be sure that it's a polynomial function? Well, I know if I take this and I expand it out, if I actually square that binomial, I know I'm not going to get anything strange, right? I'm not suddenly going to get imaginary numbers here, right? It's just multiplication. There's no imaginary terms in there as it is. There are no square roots present. There are no fractions that are magically going to appear to, wreck the domain or something. So basically, I think if I expand that, I'm going to get a traditional trinomial. X minus 3 squared is going to give me a trinomial, right? And then, of course, if I multiply that by a binomial, I'll get, again, a larger polynomial, but nothing magical is going to happen there that's going to introduce fractions, or I'm not going to suddenly get a square root in there somehow. That's not going to happen, right? So I believe that all the coefficients will remain real numbers, and all the exponents will be, either 0 or positive on x, which means that we don't have any problems with a negative exponent. So I think it's going to be a polynomial function. So I don't want to have to multiply it out to determine the degree, however. So the question is, how do I get the degree without multiplying it out? Well, let's think about something. If you squared this first binomial here, you square this, right? You're going to get something like 2, and then it'll be x squared followed by a bunch of terms, right? Okay, I'm not going to write all the terms out, although we could do that very quickly. I'm just going to, again, because I don't want to multiply it out, I'm just saying if we did multiply out, we get x squared something, 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 right? Now, over here, we have this x squared plus 2, which would then multiply times all the pieces in here, right? That trinomial that's in that first parenthesis would get multiplied by the binomial on the back end. But the biggest product in terms of exponents is going to be the first two terms, so x squared times x squared. So I'll end up getting 2x to the fourth and then a bunch of other terms, right? but no term's going to have a higher exponent than this first one here. So that means the degree here should be 4. And that's it.